Section 3.4, Partial Fraction Decomposition. We have this integral, negative 12e to the x power minus 14 divided by e to the 2x plus 3 e to the x plus 2 dx. We want to find the antiderivative. The first thing to notice is that we need to use u sub because we don't want to handle e to the x and e to the 2x. So we set u equals e to the x, then du will equals e to the x dx. Now there's something else we need to think about, okay? We have e to the 2x term. E to the 2x is the same as e to the x then square, okay? Because when you raise power to the power, you multiply the exponent. So that will be your u square. And then because we have dx, okay, so how do we replace dx? We can just divide both sides by e to the x, so du over e to the x, but e to the x is u. So this is how we replace all the items. So now we start replacing. On the top we have negative 12 u minus 14 dx will become du over u, and then e to the 2x is u squared plus 3 times e to the x, so u plus 2. Okay, for that one we can factor. Okay, so we factor it out as u plus 1 times u plus 2. And if you're not sure how to factor, use the quadratic formula. So since it can be factored, this is what we have. And because we have 3 terms involving u in the bottom, we need to think about partial fraction decomposition. Okay, so in that case, we need to find constant a, okay, over u plus 1 plus constant b. Now a and b can be negative too, okay, but we just want to use plus signs, it's easier to see, plus c over u. Okay, so all these with respect to u, so we integrate those, and we should, if you know the constant a, then let's take this example. If you know the constant c, then the antiderivative is just natural log of absolute value of u and then multiply by c in the front, right? So that we can, if we know this constant value, this integral is easy to deal with. But how do we figure out a, b, c? So because we want these two quantity to equal, okay, so this quantity must equals this quantity. We have to solve this equation. So what we need to solve is negative 12u minus 14 over u times u plus 1, u plus 2 must equal a over u plus 1 plus b over u plus 2 plus c over u. Okay, and the order doesn't matter, because if you switch the order, like you switch b over u plus c over u plus 2, then b and c just different number. So now how do we solve for a, b, and c? We need to set up linear equations. So how do we do that? Well, we don't want to deal with fraction, so we multiply both sides by the common denominator, right? Or just a denominator. So we multiply both sides by this quantity right here. So we will get negative 12u minus 14 will equal a times u plus 2 times u, right? So a u squared plus 2a u, okay? Then the next thing is for b times u plus 1 times u, so it's b u squared plus bu. Then the last one is c, so c times u plus 1 times u plus 2, so it's c u squared plus 3cu plus 2 times c. We want these both sides to equal, okay? So if you combine like term, so which is what we learned in college algebra, right? So we will get negative 12u minus 14 will equal a plus b plus c u squared plus 2a plus b plus 3c u plus just 2c as a constant. So then we need to notice, okay, there's no u squared over here, so we must have a plus b plus c equals 0, and the constant term is negative 14, so 2c must equals negative 14, and the first power, right, is negative 12, so we must have 2a plus b plus 3c equals negative 12. Now this is just a matter of solving a linear equation. The easiest one to solve is this one, right? 2c equals negative 14, c equals negative 7. Oh, negative 7. Once you know c equals negative 7, you plug it in here and there, right? So a plus b must equal 7, because a plus b equals 7 plus negative 7 will equal 0. Same thing right here. So negative 7 times 3 is negative 21. Both sides plus negative 21 here, right? So 2a plus b minus 21 equals minus 12. So this must equals 9. And how do you solve this system of equation? Well, you subtract the bottom equation from the first one, you will just get a equals 2, and then because a equals 2, b must equals 5. And if you're not sure, right, you can just go here, okay? You can just go here and check it, like plug it in. A is 2, b is 5, c is negative 7. U plus 1 plus u plus 2 plus divided by u, right? If you're not sure, what you can do is you can combine these three fractions and see if you get this one back. Okay, so I mean mainly focus on numerator, if you get the numerator back. If you do, then you know your answer is correct, and this is the correct answer anyways. So then you can just integrate, right? And notice that one thing is important to understand is e to the x. If u equals e to the x, right here, it's already telling you that u is greater than 0, okay? So in that case, you don't need the absolute value. So when you do the integral, okay, it's just, integral, antiderivative, you get ln u plus 1, okay, and that is 2 in the front, plus 5 ln u plus 2. Then you minus 7, okay, ln of u, then plus the constant c. But we're still not done yet. We have to change everything back to x in terms of x. So you get 2 ln of e to the x plus 1 plus 5 ln of e to the x plus 2 minus 7 ln of e to the x is just x, okay, because the identity, okay, so ln of e to the x, natural log of e to the x. What is the exponent? The exponent is just x. And then at the end you plus the constant c. Okay, this c is different from the little c up there. So this is a solution for this problem.